So let me just do some alignment. Okay. So let's record the start time is 6:12 a.m. Okay, then let's see what time do we end. So as usual, we will have to go follow step 1 under step 10. Right? So we'll start with step 1, create drawers. The title of this chapter is Electricity. It is a Form 5 Electricity, Chapter 3. So there are 4 drawers. Drawer 1 until drawer 4. Current and potential difference. Resistance. Electromotive force, short form EMF. And internal resistance. Drawer 4, energy and power, electrical power. So how do you remember the name of the drawer in sequence, these 4 drawers? So I created this main story. Current project director resists Ella's mom and force her to eat flour. Right. So how does it help us to remember the drawer name? Current is current, but the current for in the story is now, but the current in the drawer is not now. It's a current of the electricity. If you do not know it now, don't worry. You're gonna know it later. What is current in electricity? PD, project director, represent the potential difference P and D. Resist. So you can imagine there's a guy with authority. Currently is resisting. Resisting who? Okay, but before that, resist represent resistance. Sounds the same and also meaning similar. Resisting who? Resisting Ella's mommy. And force. So this is to represent EMF. It can be Elise mommy. It can be whichever friend of yourself that have a name starting with E. Right. For my case, I put it as Ella. Ella mommy. And force her eat flour. Eat flour is energy and electrical power. Why F? Because flour sounds like power. Right. I think it's better to have flour rather than eat power, because eat power is quite vague for you to imagine what is eat power. So eat flour sounds a bit silly. So somebody is resisting Ella's mommy and then force her to eat flour. Right? So you can yes, I have the story. Let me just give you the story. Let's see whether this can help you to remember the main story easier. Electricity. Okay, just give me a second. Where did I put that link? Okay, let me just search for my YouTube. Just give me 1 minute. Bear with me, please. I created a video yesterday. Wave. Okay.
Form 4. Being a great phone.
Sorry, it's not wave. It's electricity. Yes.
Form 4. Waves. Water wave.
Okay.
Now damp. And resting.
What have I done? Electricity. Yep, it's here.
SPM Form 5. Chapter 3 Electricity. Project Director resists Alamom. Force her eat flour.
All right, supposed to eat flour, but however, the AI did not picture it as a eating flour. Right. Maybe you can imagine that the project director is forcing Ella's mommy to eat flour, but Ella Mami did not happen to eat the flower. Okay, let's watch it again. Only a few seconds. Let's hope that few seconds is able to help you to remember main story easier.
PM Form 5, Chapter 3 Electricity. Project Director resists Ella Mom. Force her eat flower. Drawer 1.
Okay, we will watch this drawer 1 later. Okay, so that few seconds of the animations, the cartoon, I hope it will help you to remember the drawer. Right. I would suggest Xingling and Aiden, if you can write it down, just a few words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just 10 words on the paper, because you're going to use this as a reference a lot later. And even if you can write down the drawer name, it's even better. Right? So I'll give you 1 minute to write down if you want, while I'm setting up my clock. Okay, let's start 1 minute. 30 seconds, I'll give you 30 seconds. Because you're going to use this as a reference, you're going to refer to it quite often, and it's going to help you to remember the name of the drawer and also the main story. All right, now let's start with step 2. Right, you see, usually step 2, we can view the whole thing in one screen, but this one, because it is having too many new terms and formula, we have to divide them into like 2 screens. Drawer 3, drawer 4, drawer 5. Drawer 3 and drawer 4, only 4 drawers. And yeah, is it? Yeah, 4 drawers, yes. So drawer 1 here and drawer 2. Okay, let's start by reading drawer 1 and drawer 2 in 1 minute. But bear in mind, at the scale of 1 to 10 for understanding, you are at 1 now. Or maybe 2 once you finish reading this. 2 means what? 2 means you do not fully understand. You don't even understood half of it. And that is fine. So don't worry when you are reading this part and you are worried about, what am I reading? I do not even understand fully. It's fine. You just need to know there are, for example, electric field strength, then there's some current, and there's what is potential difference, because obviously the title itself, the chapter is talking about current and potential difference. Right, so obviously they have to give you some information regarding the definition and also the formula, and also how you derive the current and potential difference. Right, so let's do 1 minute and read drawer 1 until drawer 2. Start now. To increase your understanding from 1 to 2. Thirty seconds. All right, done. So how do you read this? You know that there are 5 key messages in this drawer number 1. What are the key 5 messages? Electric field, strength, current, potential difference, behavior, and observations. Right. If you do not understand fully what you have read, that is fine, and that is normal, because you just started it. Then for drawer 2, you also have 5 key messages. The definition of resistance. what is this Ohm law, what are the factors, the classification of materials, and there are two types of circuits, series and parallel, right? And you know that there are quite a few formulas inside each of them. And you have unit, and you have some definition. So formula, definition, unit. Formula, definition, unit. Same goes to field strength. Formula, definition, units, right? Don't worry if you do not remember all the information, what the formula or even the name of the units. Don't worry. You just need to know that there is something that you need to learn, and you definitely learn at the end of this class, which is about 2 hours later. There's a formula, definition, unit. All right. So let's continue on drawer, the second part, drawer 3 and drawer 4. Let's start now for 1 minute. For those who want to read back this part here on drawer 2, then you can do it if you have time. But start with drawer 3 and drawer 4. Thirty seconds. Right? Time's up. Now, you have, again, 2 drawers, like just now. You also have 2 drawers. I hope by now you should be able to remember the name easier, the name of the drawer. Then also you have 3 main messages. The previous 2 drawers you have 5, and this you have 3. So obviously the name of the drawer is telling you that you have to learn EMF and also internal resistance. And no doubt there are information related to EMF, the definitions, and also to explain what is this, and plus the internal resistance. Then you have the cell arrangement, something related to what you have learned just now, the type of circuits, series and parallel. For drawer 4, you have also 3 points. Right, like I said earlier in this class, there are many formulas and new terms that you need to understand. So that's the reason why this chapter is a bit difficult than the previous few chapters that we have learned. But it's fine. By end of the 2 hours, hopefully, you are able to reach the level of 9 or even higher. Right? And this is proven. I think by now you should have this confidence. Attending 2 hours of the chapter, of the class, you definitely get a good understanding about the chapters, as long as you are following from step 1 until step 10. Right? So now, your understanding about this chapter should be at maybe at the level of 2. 1 to 10, 1 is the lowest, 10 is the highest. You should be at the low level of 2. Obviously, we want to have a higher level. So let's try to reach to the level of 3 by going to step 3. Right? So now we are in step 3, reading the summary. How do you read the summary? Bear in mind that it is also having the sequence of the drawer. You're going to read drawer 1, 2, and until 4. And also bear in mind that, let's see this. This is the reference, right? On the right side is the reference, the keynotes. There are 5 key points. I also have 5 key points in step 3. This is step 3. On the left side is step 3. So you have 5 key points, more or less the same sequence, right? More or less the same sequence. What is the difference here? The difference here is on the left side, which is step 3, you have a bit more information than what you used to have just now when you were reading step 2. So that is how we are building your knowledge, like Lego. Your understanding of that knowledge, of the chapter, and the depth of your knowledge should be increased by level 3 by now. Sorry, not by now, by you finish the step 3, right? So I need you to have this intention that by reading this step 3, what is the objective? Your objective is to move the understanding level from 2 to 3, 2 to 3, and that's it. You're not trying to move from 2 to 10, 2 to 3, and that's it, right? So you just need to have a little bit more information that you used to have 5 minutes ago, and that's it. Okay, so let's do this drawer 1, current and potential difference, and we'll read. Let's see how long is this. Okay, it's quite long, so we'll take maybe 2 minutes for each part. You can divide it into 2 parts for drawer 1. And how do you read this? When you read this, you also need to read on the right hand side step 2 as your reference. So for example, you are reading electric field production, electric field patterns. So it is related to this point number 1 here. 2 points here is related to 1 point here. Then 3.3 here is related to point 2 here. So you cross-check what you have read just now that you did not fully understand, and then what do you read now in chapter and in step 3 that you understand a bit more. A bit more. I'm not expecting you to understand fully. Just a bit more is fine. Okay? Let's start now for 1 minute. Read from here to here. Okay, so by now you should have increased your understanding level for drawer 1.1 to level 3. What exactly is level 3? If you are doing an exam and if you get 30% out of 100%, and that's our target now. 30% is fail. Fail means what? Means you do not fully understand. And if you do not fully understand by now, after reading this, and that's normal, and that's what we are expecting, right? But you're not at 0. You already understood that there is something related to the field, there's something related to the pattern, there's something related to the repulsive and attractive, depending on what charges the particles are, positive or negative, positive, repulse, negative, repulse, positive, negative, attract, like girl and boy attract, right? For example, yes. So if you are at that level, then you are fine. You are following the progress of this brain drawer method, right? Because you are still at step 3. Step 3 is 30%. 30%. 30% is not pass, it's fail. Fail means you do not fully understand yet, but you understand a little bit more than 5 minutes ago. And that is fine. And that's what we are expecting, right? So let's do this. So let's do the second part for 1 minute. All right. I think let's do this for 1 minute. Sorry. The candle flames, I'll cut it for the third part. Let's do from potential difference until the polystyrene ball. 1 minute. right? So by now you should have a little bit more understanding about potential difference, right? Potential difference is an energy transfer per unit charge. And what's this unit charge that we are talking about here? The Q, right? The Q. Let's do the candle flames plus some part of the balls, polystyrene balls, for 1 minute. Ten seconds. Right, it's done. Right, I think I've emphasized this on every class, that I'm not your typical physics teacher. As you may realize now, by now, I did not actually teach you what is electricity, what is field, what is current, what is potential difference. I did not do that. I'm teaching you a method, a study method that can help you to be able to understand the concept of that chapter easier, right? Okay, let's continue on drawer 2. So same thing, drawer 2 on your right, which is the keynotes. There are 5 key points. So you should be expecting similar 5 key points in your left-hand side of step 3 notes. Step 2, right. Step 3, left. And step 3 having more information than step 2. So we are building Lego. And you should be expecting, your target is to increase your understanding level now at level 2 for drawer 2 to level 3, not level 10, only level 3, and that's it. Right? Let's do that in 1 minute by reading drawer 2 until here. Let me see what. Okay. We'll divide it into 2 parts. Let's start now. Right? So it's done. So drawer 2 is resistant. And this is the point 1, 2, and 3. And now by now, if you read again this 1, 2, and 3 here, step 2, your understanding should be a little bit higher than maybe 10 minutes ago when you were at step 2 reading this. Right? If you have that feeling, then you're on the right track. Right? Okay. Let's continue for 1 minute here. right? Time's up. So let's continue. The same drill, same method, but now for drawer 3. Drawer 3 is having 3 key points, right? So let's read this part, drawer 3. Let's start now. Fifteen seconds. Time's up. Don't worry about memorizing or remembering all the formulas for now. Don't worry about that, right? As long as you are now at level 3 for drawer 3, then you are fine. Okay. Okay, let's do this part here. This last part for 1 minute. Whoever who finished the last part, you want to reread the previous part. Then let's do that. You have 1 minute. Ten more seconds. All right. So let's say now you read this highlighted part again. I think your understanding now is a bit higher than 10 minutes ago when you first read this in step 2. Now you're in step 3, right? So now let's continue on the last drawer. Last drawer, I'll also divide it into 2 parts. I'll give you 1 minute for each part. Ten more seconds. Okay, time's up. I'm going to slow down a bit more. I'll give you 1 more minute. All right, you can read again if you have read it all. If you do not understand fully, you can read again to increase it to a solid level 3. 20 seconds. All right. So we'll move on. We'll move on to step 4. We're halfway through. I'll move on to step 4. And how do you read step 4? It's also divided into drawers. Every questions, there is answers. And they're divided into drawers. So I want you to intentionally always refer to which drawer you are reading now. And this one is very obvious. Current and potential difference, which is drawer 1. Remember the very serious project director, right? And that is the potential difference. So there are 8 questions. We're going to take a rest for take a break for 5 minutes after 8 questions. Now is question number 1. So how do you read this? You read these questions. For example, how do electric field influence the movement of charge within a system? So whether this is in which part in this first drawer, right? It's a combination of, I believe, a combination of 1, 2, 3, and 4, right? So let's read this with the intention to now bring your understanding level from 3 to 4, not 10, not 9. Don't set a high expectation for you. 3 to 4, just a little bit more than what you understood 5 minutes ago when you were doing step 3. Okay, let's start 1 minute for this question number 1 and answer. $15 seconds. I'll give you 30 more seconds. So 1 minute and 30 minutes. 1 minute and 30 seconds. I think 1 minute is too short. Let's do again. 30 seconds. 30 more seconds. Okay. I hope now you are able to improve your drawer 1 from 3 to maybe 3.5, because we have second questions, right? So second question, I'll intentionally leave the question number 1 visible in case you want to reread it again. If you miss something, you can still do it, right? So now focus on question 2. All right, I'll put it as, where is it? I'll put it as 2 minutes per questions. I think it's question 1 minute is a bit too fast. Okay, how do I set this? Give me 1 second. Okay, save, pull it back. Okay, drawer 1. We are still at drawer 1. Question 2 for 2 minutes. Start now. If you finish reading question 2, you can continue, read again, or read the question 1 that you missed above. Fifteen seconds. All right, so this is step 4 for drawer 1. By now, you should feel that your understanding level increased by a little bit more to at the level of maybe 4. If the passing point is 40%, usually in your exam, then you should be able to pass in your exam if you are going to exam doing testing your understanding on drawer 1. Right? So let's continue. I'll also give you 2 minutes so you can reread it to understand the concept. Let's start now, drawer 2. Thirty seconds. Ten seconds. Right? Thumbs up. So drawer 2, question 3 is about the resistance. Resistance is about this part here. Right? It's about this part here. Now, by reading this only, your understanding should be much higher than when you first read this. There's nothing changed. I did not change any wording here. I did not add any sentences here. But your understanding changed because now you are in step 4. Your understanding were from 2 to 4 now, right? Only on particularly this part. So let's see. Question 4 is ohmic and non-ohmic comparison, right? So it's particularly mentioning this part here. Okay, so let's do 2 minutes as well. Let's read slowly for question 4. Start now. 30 seconds. Ten seconds. Right, time's up. Let's continue on drawer 3. Drawer 3, question 5 and question 6. Okay, let's do question 5 and question 6 in 2 minutes because they are short questions. Question 5 is the numbering is a bit off alignment. How does electromotive force differ from terminal potential difference? Then question 6 is here. What are the strategic advantages of different dry cell configurations? So if you map it to the key, the steps 2, so it's talking about 1 and 2 for the first question, and 3 for the second question. Okay, let's start 2 minutes for 2 questions now. Twenty seconds. All right, time. That is drawer 3. So let's continue to the last drawer 4. We do the same thing, 2 minutes for 2 questions. Then we go for a short break. Let's start now. One more minute. 30 seconds. Ten seconds. All right. So let's take 5 minutes, a short 5 minutes break, toilet break, water break. Then we'll come back again to review step 2. Let's start now. Break start now. Two more minutes. Can I have a show of hand? Who is available now? Who is back? All right. Singling is back. Aiden is back. Marcus, are you back? Not yet. We have 30 more seconds for our break. So be ready. All right, time's up. Now, let's do this. Let's read this drawer 1 until drawer 2 again. And this time, ask yourself if your understanding compared to maybe 20 minutes ago when you started reading drawer 2, when you started reading step 2, is higher or still the same. All right, let's do it now. Let's read this for 1 minute. Ten more seconds. You should be feeling that your understanding increased. Maybe you still feel that you did not understand fully all the points, but there is at least quite a significant improvement from 20 minutes ago when you started reading step 2, about 6:12 a.m. Right, maybe 6:20 a.m. you started reading here, because we took some time to also go through this step 1. Right. So let's do the same thing. Read again for in 30 seconds this time, 30 seconds, and see whether you have the same feeling. And you should need to have this feeling. The feeling of understanding it more from 1 to maybe 4 now. Twenty seconds. Okay, time's up. Right. To the very least, you should know there are 4 drawers. And point number 1. Point number 2 is you should know the name of the drawers in sequence, not jumbled up, in sequence. And then you also know roughly what is in drawer 1. There are 5 points, key points, related to the current, the potential difference, the field. And there is formula and there is unit. For drawer 2 also, to the very least, you know what is the key points. Drawer 3, you have 3 key points. And drawer 4 also you have 3 key points. So you have 5 points, 5 points, 3 points, 3 points, 16 points. And you know the drawer's name. Still remember the story? The very serious guy, the project director in the cartoon. The current project director is resisting Ella's mommy and forced her to eat flour. Right. And obviously in that cartoon, Ella mommy did not eat flour, but the project director looks very upset. right? So now, with the intention to increase your knowledge, understanding about this chapter, from 4 to 5, we go to step 5, right? So step 5, you have a bit more details than the previous few chapters, few steps. So let's have that intention that you want to spend this 1 minute or 2 minutes to improve your understanding from 4 to 5. Right, let's do it in 1 minute now. Let's read here. Ten seconds. Right, time's up. Let's move on a bit more. Okay, let's do 30 seconds for this part, the one that you see, before we go to 1.2. Should I go to 1.2? No, let's do the 1.2 later. 30 seconds. 30. Oh, it's more than 30. Sorry. So let's do 1.2 until, let's do 1.2 and 1.3 for 1 minute. Ten seconds. Right. 1.4, also 1 minute. If you finish reading 1.4, you can read 1.3 again. Okay, time's up. That is for drawer number 1. So by now, your drawer number 1 level should increase to from 4 to somewhere higher, maybe 5 for drawer number 1. Now let's do the same drill for drawer number 2. We'll do 2.1 and 2.2, right? For 1 minute. 2.1, 2.2. I think I'll give you 1 more minute because 2.2 needs time to think. So read slowly. Okay, 1 more minute. Ten seconds. Okay, by now you should at least know the difference between parallel and circuit and series in terms of the resistance. Resistance for parallel circuits decrease as you add more resistance. However, series increase as you add more resistance. Right? It's mentioned here clearly. Series circuits, total resistance increase. Parallel, total resistance decrease because of the calculations, right? The parallel part and also the series part, right? If you now understand that there is this clear difference between parallel and series in terms of resistance, that is fine. You should know that by now. If you don't know it, I'm telling you now. If you are able to even understand why by this formula, then it's better, right? So let's continue on 2.3 and 2.4 for 1 minute. Let's start now. Ten seconds. Right. So your drawer 2 understanding level should be at the level of 5 now. Increase from 4 to 5. 5 means 50%. If you're answering 10 MCQ, you should have at least 5 correct by now for drawer 1 and drawer 2. So let's continue to build that knowledge like a Lego for drawer 3. I'll divide them into 2 parts. So let's start now 3.1 and 3.2. 1 minute. Drawer 3, let me move up. Yep, for you to have a reference. Ten seconds. Okay, let's do 3.3 and 3.4. 1 minute again. Right, time's up. So let's continue on drawer 4. Let's see how long is this. Yep. Let's do 2 minutes. 2 minutes. Drawer 4. 4.1, 4.2, 4.3. 2 minutes. Let me move up for you as your reference. $15 seconds before we continue another 1 minute. All right, let's start 1 minute again. Take your time and read in 1 minute. Ten more seconds. All right. Now, we have completed step 5. We have completed step 5. We are going to step 6, which is to create the story. Right. But before we move there, I need you to always remember the drawer. By now, I think it's already quite easy for you to remember the drawer's name in sequence. There are 4 drawers: current and potential difference, resistance, EMF, and internal resistance, energy and power. How do you remember? By just these very simple 9 words. And also we show you the cartoon, the animation just now. current project director resists Ella's mummy and force her to eat flour. Right? That is to help you to remember the name of the drawer. There are 4 drawers, and those are the name of the drawers. Current PD, drawer number 1. Resistant, resist. Ella mummy, force, EMF. And internal resistance is not here, but I hope the EMF is able to help you to trigger to remember this internal resistance. And to eat what? To eat flour, EF. E is electric energy. E for energy. Flour sounds like power, so power, electrical power, right? So we started at 6:12. Now is slightly more than 1 hour. Slightly more than 1 hour, and I believe you have now a better understanding on the chapter, right? If you were given a book to read to understand the chapter in slightly more than 1 hour, do you think you are able to understand better than what you understood now using this method? I think most likely no. If the answer is no, means what? Means this method is more efficient than your previous old method of learning. So if you also feel the same thing, then this method works for you, right? This method works for you. Okay, and let's continue on step 6 to create the stories. So now, drawer 1, the topic, the name of the drawer is current and potential difference. So the story that I've created to relate these key points is as such. Project director work hard to push Queen from point A to point B in 1 second in a football or e-football field, right? Why this story? I think by now you should have a little bit of the idea why I created this story, to relate the key informations inside this drawer number 1. Project director, which is the potential difference, work hard to push the Queen. Work hard. In the previous step 3, step 4, and step 5, the potential difference is about the work, right? The work to move the charge from one point to another point. So the project director work hard to push the Queen. Queen, the charge, the symbol is Q, right? The symbol is Q. So I use the Q as Queen from 1 point to 1 point in 1 second, right? So that is to reflect the key points that you need to know that is in this chapter, in this drawer. In e-football field, why e-football field? Electric field, right? To represent electric field. So you know there is electric field that you need to understand in this drawer. Positive, negative, attractive, repulsive, and also the force per unit charge, right? So that is the story of drawer number 1, right? Bear in mind, story of drawer number 1, the story is not a complete story that is going to tell you all the informations in the drawer, right? It's just an anchoring point to help you to refresh, right? So that is the purpose of the story. Later we're going to watch the cartoon. For now, this is how I created the story. You can create your own story if you have a better story to help you to remember the key messages, right? Drawer number 2 is resistant. Resistant is Isaac slows current speed. Resistant with long leg, small arm. Now the Buddhists, they have this Amitabha, and also use it somebody who is like a monk. and versus somebody who is not among, because it's non-ohm interval. And obviously this is clear that I'm trying to refresh myself that in this drawer there is content related to Ohm law and non-ohmic law. Right? Then we have this where IV and Rn are the referee. IV and Rn is to reflect the formula V equivalent to IR. Right? IV and R. R is Rn is my boy. That's his name. You can relate it with Richard, or you can relate it to somebody else. Then I have this formula. Right? This formula is to reflect that this is the series, this is the parallel. Remember when I say parallel, there's a big difference between series in terms of resistance. Is this resistance is lesser. So see, resistance is divided for parallel. Then resistance for series is add up. So it's getting more and more. Then for the voltage for series, it's getting more and more. But for the voltage for parallel, it's consistent. All right. So why Isaac slows current speed? I took it from here. Insulator, semiconductor, conductor, superconductor. Isaac slow current speed. You're going to see the Isaac story later. Resistant, there's this guy called resistant with long legs and small armpit. Right. Resistant, this is to describe the factor affecting resistance. So with a long legs, long is the length, long wire, it's going to affect the resistance. And also small armpit. Armpit is a cross-sectional area. It's A, so small armpit. Okay, area, A for armpit. Right. So that is the story. If you're able to follow, then it's perfect. If you're not, and you want to create your own story that can help you to remember the key information easier, then by all means, you can do it by yourself. Right? Draw 3 electromotive force and internal resistance. So this is this part over here. So there are 3 key messages. Ella, mom, fly. This obviously is to help you to remember there is this EMF in an open sky and drop on a paraglide with less resistance. Right. This is to help me to remember there is this EMF that I need to remember. I need to know. Right. The definition of EMF that I need to know. Then drop means what? Internal resistance. When there's an internal resistance, there's a drop in voltage. I think you read that key. You read this word quite a few times in step 3 and 4 and 5. Right. So that is to reflect the drop of voltage for internal resistance. And why there's a drop of voltage? Because there's internal resistance, and how this internal resistance is being created. These are the information in step 3, 4, and 5. Then paraglide, less resistance. This is to reflect parallel circuits, less resistance, right? Because here also is having the information related to parallel, right? So this is to help me to remember the key messages in drawer 3. For drawer 4, I hope everyone is still following. Marcus dropped because he has a meeting to attend. So I hope everyone is still following, right? Drawer 4, energy and power. Wendy is powerful. Victor push hard. Amy flow fast. P equivalent to VI. This is the formula. LED versus CFL. I think you see this quite a few times in step 5 and step 4. The difference between LED and also CFL type of light. LED is more efficient and is lower and use lower energy. That means you do need to pay high electric bill compared to the old light that is using CFL. Right. So why Wendy powerful? Wendy power. Okay, let's look at it. Right. Why Wendy is powerful? Because Power is using watt. So this is to help me to remember power unit is watt. Then Victor push, voltage is about pushing, right? Voltage is about pushing and to make some work to push from one point to another point, similar to the potential difference when the PD is pushing the queen from one point to another point, right? This is to help me to remember. PVI, right? P is power, voltage, and I is current. Current is flowing. The faster you flow, the better it is. So Amy flow fast. So you have three characters over here. You have Wendy, you have Victor, and you have Amy. Three are doing three different things. That is to reflect this formula, P equivalent to VI. Okay, LED and CFL, I think I already explained that. So this is the story that I draw. I know I'm not a good artist, so this is the best that I can draw to help me to remember, right? But I also created the cartoon for us to be able to remember easier the story. Let's go and watch this cartoon and see if this helps.
SPM Form 5, Chapter 3 Electricity. Project Director resists alarm. Force Harit flower. Drawer 1. Current and potential difference. TD work hard to push queen. Pointed to be in 1 second in a football field. Drawer 2. Resistance. Isaac slows current speed. Resistance with long legs, small armpit. Omitabha versus non-Omitabha, where Avi Ran are the referee. Drawer 3. Electromotive force and internal resistance. Ella mom fly in an open sky. Drop on a paraglide with less resistance. Drawer 4. Energy and power. Wendy powerful, Victor push hard, Amy flow fast.
All right. So that is, hopefully that very short video is able to help you to remember the story. Why the story is important? Because that story will help you to remember the content, the key information in this chapter. Right. And this picture, what is the role of this picture? When you are in the exam hall, imagine that you are going into an exam hall. Are you able to bring this YouTube link to the exam hall? No. Do you think that you are able to remember all this key information? Or you can write it down in a paper? I don't think so, right? But do you think that you are able to draw these four pictures with the story in a paper? I think yes. And that is the easiest that you can do in the exam hall before you go for an exam. And this will help you to remember the key informations inside the chapter, right? PD pushing the queen. You remember the queen was being pushed and she was running from A to B in the football field, right? Resistance, slow current speed. Then you have this omitable and non-omitable. And then you have a resistance that is having long legs and a small armpit, right? Then you have this Ella mom, and then she dropped on a paraglide and having less resistance. Then you saw this now, the last one. You have Wendy, who is a very powerful lady. You have Victor, who is pushing something. And then you have Amy, who is flowing very fast, right? So that is to help you to remember, to maintain you at level 9. Now you're at maybe level 6 now, because you're already at step 6, right? So I hope you are still following, right? I hope you are still following. If you are still following, please put a thumbs up. Also, I need to know that you are still with me. Okay, that's good. Now, step 7. So now your understanding should reached to the level of 6 now. Now we are trying to move it further into 7, right? Into 7. So how do you do this? Read the questions and intentionally try to ask yourself, what drawer is this related to? Obviously, you have the answer because I put the answer over here. But the attempt of trying to answer the question to ask yourself whether this is drawer 1, drawer 2, or drawer 4, this will help you to remember the drawer. All right. Before reading the answer, which is a very short answer, try to form by yourself some answers in your brain. Then read the questions. Then read the answer, sorry. Okay. If there is new information that you discover, then put it back into your drawer. Right? So let's do 2 questions, 1 minute for 2 questions. Let's start now. 1 and 2. Thirty more seconds for question 1 and question 2. Right? Question 1 and question 2 done. You should have a little bit more new knowledge or solidifying, reinforcing what you have learned in drawer 1 and drawer 2 by reading this and answering these 2 simple questions. Right. So let's continue on question 3 and 4 for 1 minute. Let's do the same drill. Thirty seconds. Question 2 and 3. Okay. Sorry, is it question 2 and 3? Should be 3 and 4, sorry. 3 and 4. 10 more seconds. Okay. Let's go to 5 and 6. Same drill. 1 minute. Start now. Twenty seconds. Ten seconds. Okay. 7 and 8. Let's start now. All right, last two before we move on to watch video. Let's start now. Ten more seconds. Okay, let's watch the video.
All right, today we are diving deep into that invisible force that, let's be honest, runs pretty much everything in our lives, electricity. We're going to start with the super basic stuff, the push and pull of tiny charges, and by the end, you'll have a whole new way of looking at your monthly electricity bill. So let's jump right in.
Okay, so here's our game plan. We've got it broken down into 4 key parts. First, we'll get into the nitty-gritty of what actually makes electricity move. Then, we'll look at what tries to slow it down, because it's not always a smooth ride. After that, we're going to crack open a battery and find out where its power really comes from. And finally, we'll tie it all together to see how this affects the power grid and, well, your own home.
So let's kick things off with a little puzzle. You've got this massive, chaotic bolt of lightning, and then you've got this simple, everyday act of charging your phone. What on earth could they possibly have in common? Well, it turns out, pretty much everything. They are both fundamentally about the same thing, moving electric charges. Just, on a slightly different scale.
So let's start at the very beginning. Section 1 is all about those invisible forces, the fundamentals that get electricity going from point A to point B.
It all begins with this thing called an electric field. Think of it like an invisible force field that surrounds any charged object. You've probably seen this cool party trick, right? Where you charge up a comb by running it through your hair, and then you can actually bend a thin stream of water from a tap without even touching it. That unseen push you're witnessing, that is the electric field at work. It's wild.
Okay, so once those charges start actually moving through something like a wire, that's what we call an electric current. And honestly, the best way to picture this is to think about water flowing through a pipe. The amount of water that's gushing past any given point every second, that's your current. And we measure this flow in something called amperes, or just amps for short. But what makes that current flow in the first place? It doesn't just happen on its own. It needs a push. And that push is something called potential difference, which, thankfully, we usually just call voltage. So, sticking with our water analogy, if the current is the flow, then voltage is the pressure behind it. It makes perfect sense, right? No pressure, no flow. And in the world of electricity, no voltage, absolutely no current. All right, so we've got our flow and we've got our pressure. But the journey for that current isn't always smooth.
Right, just now was drawer 1. If you did not realize, it was drawer 1. Now we are going to drawer 2, resistance.
Sailing. Just like a water pipe can get narrow or clogged up, electrical wires have this property that, well, it pushes back against the flow. And this pushback is what we call resistance.
And here's the thing, not all materials the same way. Some are really predictable. We call them ohmic conductors. Their resistance is just constant. But then you have others, the non-ohmic ones, and they're a bit more interesting. A perfect example is the little filament inside an old-school light bulb. As it gets super hot, its resistance actually goes up. It changes with the conditions.
So that brings up a really good question. What actually determines how much resistance a wire has? It turns out it really just boils down to 3 main things. Okay, so here are the big 3. First, you've got length. Makes sense, right? The longer the wire, the more stuff the electricity has to push through, so higher resistance. Second, cross-sectional area, which is just a fancy way of saying how thick the wire is. A thicker wire is like a wider pipe. It gives the current more room to flow, which lowers the resistance. And finally, there's resistivity. This is just built into the material itself. Some materials are simply more resistant than others. And physicists, being physicists, came up with a really neat and simple formula that ties this all together.
Resistance, or R, is just that resistivity value, rho, times the length, L, all divided by the area, A. It's a super elegant way to capture that whole relationship in one little equation. And this is where things get really practical, because we can actually use this to our advantage. Think about a rice cooker or a toaster. For the part that heats up, we want high resistance, so we pick a material like nichrome to get it really hot. But for the power cord connecting it to the wall, we want the exact opposite. We use a low resistance material like copper to make sure all that energy gets to the appliance without the cord itself heating up. It's all about choosing the right tool for the job.
Okay, so now that we get the idea of flow and resistance, let's go to the source.
Number
Where
three.
does that initial push even come from? Let's take a look inside a battery to figure out what given it its inner strength.
So deep inside every single battery is something called electromotive force, or EMF for short. Now, the name is a little confusing. It's not actually a force, it's a measure of energy. Really, it's the total, absolute maximum push that a battery has to offer before you even plug it into anything. It's its raw potential.
And this is a really, really important distinction to make. EMF is what the battery can provide in a perfect world, its total potential. Voltage, on the other hand, is what it's actually delivering once the current starts flowing. Think of it as potential versus actual performance.
This actually explains something you've probably seen happen. You get a brand new 1.5 volt battery, right? But the second you pop it into your remote and start using it, the voltage isn't quite 1.5 anymore. It drops a little. So what's going on there? Why does that happen?
Well, the answer is internal resistance. It turns out the stuff inside the battery, the chemicals, the electrolytes, it has its own resistance. So the battery actually has to use up a little bit of its own energy just to push the current out of itself. It's like the battery has to pay a tiny little self-tax on every bit of power it sends out.
And knowing this is absolutely critical for engineers. We can put batteries in a line, or in series, to add up their voltages and get a bigger push. Or we can put them side by side, in parallel, which is really clever because it lowers the total internal resistance and lets us deliver more current for a longer time. And this isn't just theory. This is exactly how the incredibly complex battery packs in electric vehicles are designed.
All right, for our last section,
Roll call.
let's bring it all home. We've talked about the theory, so now let's connect all these ideas to what we actually use and pay for every single day: electrical energy and power.
You see the word watt on pretty much every appliance you own, right? Well, that's all about power. Power is simply the rate at which something uses energy. So when you see a 100-watt light bulb, what that really means is it's burning through 100 joules of energy for every single second that it's turned on.
But here's the thing. Our electricity bills aren't really based on watts. They're based on how much energy we use over a period of time. And that's where the kilowatt hour comes in. It's just power multiplied by time. And if you look at your bill, you'll probably see that 1 kilowatt hour is just called 1 unit of electricity. That's the thing you're actually paying for.
And this choice of appliance has a huge impact on your wallet. Just look at this chart. We're comparing the monthly cost to run 2 different light bulbs that give off the same amount of light. The older CFL bulb, it costs more than 3 times as much to run as the newer, super efficient LED bulb. Over a year, that really adds up.
So what's the big takeaway here? We can all make smarter choices to cut down on our energy use. I mean, sure, switching to efficient things like LED lights is a no-brainer, but even simple habits, like actually switching stuff off when you leave a room, only running when it's full, and making sure your doors are closed when the AC is on, all of that makes a real measurable difference.
So there you have it. We've gone from the invisible push of an electric field all the way to the numbers on your monthly bill. We've seen how voltage pushes, current flows, and resistance, well, resistance resists. So the final question is for you. Now that you understand this incredible power a little bit better, how will you choose to use it?
All right. How will you choose to use it? Interesting questions. Now, by now, your level of understanding this chapter, I think it increased by a lot. Let's assume it is level 8 now. Let's see whether we can push it further to level 9 by just listening to this few minutes for podcast.
If you take a statically charged comb,
All right, I'm going to display the reference here, and I'm going to highlight which part this lady and the gentleman is talking about. So it's about 5 minutes podcast. Let's start now.
And hold it near your kitchen sink. The stream of tap water will actually bend through midair.
Yeah, it's a wild thing to see.
Right. Well, welcome to the invisible push of the electric field. Today, we are doing a deep dive into the journey of electrical energy.
And giving you, the listener, a sort of shortcut to understanding the forces powering your daily life.
Exactly. From that microscopic push to, well, the very real energy bill sitting on your kitchen counter.
Because it's a sequence that governs basically everything you touch. We're
Yeah.
going from current and potential difference straight through the bottlenecks of resistance.
And then into the internal chemistry of power sources, before finally landing on raw energy and power.
Right. So let's unpack that initial push. We all know electric fields cause charges to move.
Yeah, but the sheer scale of the energy transfer is what's really wild here.
Oh, absolutely. Like when we talk about potential difference, it's not just some vague pressure.
No, it's a strictly defined amount of work, right?
Exactly. It is the exact energy transferred to move a single coulomb from point A to point B.
And a coulomb isn't just, a single stray electron.
No, I mean, it's essentially this massive specific cluster of roughly 6 quintillion electrons.
Wow, 6 quintillion.
Yeah. And the energy required to shift that massive cluster is measured in volts, which, by the way, honors Alessandro Volta and his early chemical batteries.
So the voltage is basically doing the heavy lifting, pushing that massive cluster to create the current.
Right, but it is never a clean ride. Like, the electrons immediately hit a bottleneck.
Resistance.
Exactly, resistance.
But here's what I wonder. If resistance just opposes the current and converts that potential energy into wasted heat, isn't that just a fundamental flaw?
Well, you would think so.
Right, like why haven't we engineered it out of our devices entirely?
Because we don't always want to get rid of it. Often that waste is the entire goal.
Wait, really? The waste is the goal?
Yeah. Think about your rice cooker. It doesn't just tolerate resistance, it actually requires it.
Oh, so the nichrome wire inside the heating plate is a deliberate bottleneck.
Exactly. It's a high resistivity bottleneck. We are intentionally forcing those fast-moving electrons into a microscopic traffic jam.
So their kinetic energy just radiates out as heat to cook your food. We're basically weaponizing the friction.
We really are. I mean, the only way to bypass it completely is with superconductors.
Right, which can hit absolute zero resistance.
Yeah, but only at extreme freezing critical temperatures. So for everyday heating appliances, we just exploit the friction instead.
Okay, but we've talked about the resistance in the wires. The real bottleneck actually starts before the electrons even leave the power source.
Yeah, this is a huge point. Like a brand new 1.5 volt battery isn't actually delivering 1.5 volts to your circuit.
Because it's fighting its own internal chemistry the second it connects.
Right. The electrolytes inside the battery create their own internal resistance. So you have the electromotive force, or EMF.
Which is the total potential energy supplied when circuit is open, that perfect 1.5 volts.
Exactly. But once the current actually flows, you lose some of that energy just pushing the charge through the battery's own materials.
You're losing energy just getting the charge out the door.
Yeah, and that becomes a massive engineering hurdle when you scale up.
Oh, I bet.
Like, this is why electric vehicles arrange their battery cells in massive parallel circuits.
Oh, because when you wire cells in parallel, you're providing multiple simultaneous paths for the electrons to travel.
Right. It vastly reduces the effective internal resistance.
It is like opening 10 extra checkout lanes at a grocery store. You aren't changing the total number of customers.
No, but you're vastly reducing the friction to get them out. Congestion just drops completely.
And that drop allows a massive flow of current directly to the electric motor.
Exactly, without boiling the battery pack in its own internal heat.
That is brilliant engineering. And all of these mechanics, the push of the voltage, the flow of the current, managing the resistance, it all ultimately passes out as power consumption.
Right. It is what you actually pay for. Power is simply current multiplied by voltage.
And managing that equation is where modern efficiency really comes in.
Oh, totally. Take a 40-watt compact fluorescent lamp versus a 12-watt LED.
They output the exact same brightness, right?
Yeah. But the LED operates with vastly higher efficiency.
Because it navigates the flow and resistance with far less wasted heat.
Exactly. Doing the same visible work while pulling a fraction of the power from the grid.
Which is why it's so much cheaper to run. So what does this all mean for you?
Well, we have traced the invisible push of an electric field.
We've seen how to harness deliberate bottlenecks to cook our food.
And how splitting checkout lanes, so to speak, drives electric cars.
But think back to those superconductors we mentioned earlier.
Right, the ones that only achieve zero resistance in deep freezes.
Exactly. If scientists ever crack the code for room temperature superconductors, how would eliminating internal resistance and energy loss entirely revolutionize the devices, the vehicles, and the power grids you rely on every single day?
All right. How do we do that? Let's think. Now, we are 8:01 now. In less than 2 hours, I think you also feel that you understood the chapter quite well. Maybe not 100%, not exam ready yet, but you understood the fundamental, the concept of the chapter. So let's do a test. Right. Let's assume that now you are in, this is level, you were in level 1, and now you are in, you feel that you are in level 9. All right. So let's do a test to see whether what you felt is really who you are. Electricity. Right. Ask me 10 MCQ one by one without answer and list out the drawer name and number. Yeah, let's try. All right. Let's do an assessment to see whether you understood the chapter well. Okay. Let's do let's two questions at once at a time. Okay, let's do the same thing. Tell me which question and which answer. Do not need to tell me the drawer because I already mentioned the drawer. Let's do it. Aiden, Singling, I see Singling is typing, which is good. Question 1 was the answer. Question 2 was the answer. You can use this as a reference. Keynotes. B and C. What about Aiden? Aiden, you're not typing. Do you feel the same answer? All right. Okay, both are having the same answer. Let's see. Both correct? Okay, let's continue. No worry, Aiden. 3 and 4. Three, A or B? 4? Anyone want to try 4? Ohmic and non-ohmic. Remember? Ohmic is what? Non-ohmic is what? Okay, so 3 is B. Aiden also agree that it's B. 4 is C. Both. Okay, let's see. It has constant resistance when temperature is constant. Nice. Question 5 and 6. Let's do it. Five is B from Singling. Also B from Aiden. Now let's try 6. B from Aiden. Okay, both have the same answer. Well, excellent. 7 and 8. Which formula correctly represents electrical power? What is the unit of electrical energy? Seven A, 8C. Aiden, waiting for you. Seven A, 8. Eight A. Okay, so there's a different in. Okay, let's try C. Let's try A. Let's see what is the answer. All right. So Singling got it right. No worry, Aiden. So you understood there is new information. Take it and put it inside your drawer. Okay. Joule. Let's do 9 and 10. Nine is D. D and B. B or D. Okay, let's wait for 10. Let's wait for number 10. Either A or C, you don't remember. All right, let me try to help you to remember. Which one is bigger? Voltage, terminal voltage, or EMF? EMF is the potential without calculating the internal resistance yet. Remember in the video or in the podcast, they mentioned if your battery is showing 1.5 volt, but when you start to measure it, it is less than 1.5 volt. So the terminal voltage is lesser than the EMF. So if that is the case, A or C? Right, C. Okay, for question, yes, Aiden also got it C. So but question 9, Aiden answer it as D. It's not D because if you increase temperature, the resistance increase. Right, increase temperature, the resistance increase. Remember the formula, this one. So if your length increase, the resistance increase. If your area increase, the resistance decrease. So it's B. All right, 9 out of 10. Even if it is 8 out of 10, it's also very good. And we did it only in, now it's 8:13, in 2 hours. 2 hours and 1 minute. Right? I think it's an excellent class, and you got the concept right. So now, next question is, how do you maintain yourself at level 9? How do you do that? You have to do this. You have to do this. You have to do this, the 10 minutes revision. Right? If you do this every 10 minutes, then you are able to maintain it at 9. Right? And if you want to push it more, obviously you need to do past year questions, you need to do more exercise, then you can move from 10, 11, 12, 13 until the level that you think is good for you. Right? So that's it for today. Hope you enjoy it and you learn something. So let's try to meet again next week for another chapter. All right? Thank you. Bye-bye. Okay, I'll make a move. Bye-bye. Thank you, Singling. Bye-bye.